Hello, I'm Lynn Bondurant. Welcome once again to our series about American air and space efforts during a quarter of a century. During this third episode, we cover 1962 and part of 1963. In those years, NASA is working to prepare for manned flights to the moon. To put 1962 into historical perspective, it is the year in which the book Silent Spring by Rachel Carson helped spark the environmental movement. And 1962 is the year John Glenn makes the first U.S. spaceflight around the world on February 20th. Friendship 7, with astronaut Glenn aboard, waits atop the 93-foot-tall Atlas launch vehicle. The countdown reaches the final seconds. Astronaut Glenn is in orbital flight 100 miles in space. His voice reports are accurate, coherent, and prompt. The space pilot has no problems reaching for controls. Chewing and swallowing of food are easy. Glenn experiences no vertigo or nausea, even as day turns into night 17 times faster than normal. On the night side, the pilot reports the horizon is always visible. At the end of the first orbit, a malfunction in the automatic control jets occurs. The problem continues throughout the rest of the flight. The problem is an opportunity to prove man can take full control of the spacecraft. On the third orbit, after manually maneuvering the spacecraft, the retro rockets fire when the craft is just off the coast of California. There are heat shield problems too.
We are recommending that the retro package not, I say again, not be jettisoned. 5G switch, which is expected to occur at 044353. This is approximately 4.5 minutes from now. This also means that you will have to retract the scope manually. Do you understand?
Friendship 7 arcs down into the Earth's atmosphere. As it decelerates, the effect of ionization around the spacecraft temporarily blocks communications. The heat shield is about 3,600 degrees.
Retropack upon reaching 1 to 1.5 G. Do you understand? Over. 7, this is Cape. Transmitting blind.
Keep talking, Al.
Friendship 7, this is Cape. Over. Friendship 7, this is Cape. How do you read? Over. 7, this is Cape. Transmitting blind. Your IP is within 1 mile of the uprange destroyer.
The spacecraft vibrates excessively. The drogue parachute deploys earlier than planned, stabilizing the craft. 9 minutes before landing, the recovery forces begin searching the landing area. The destroyer, USS Noah, has the spacecraft in sight. After 4 hours and 56 minutes, astronaut Glenn in the Mercury capsule completes the first United States manned orbital spaceflight. 18 minutes later, the USS Noah recovers the spacecraft from the sea. Post-flight examination shows the astronaut is in excellent health. In the meantime, NASA moves its Manned Spacecraft Center from Langley Station, Virginia, to Clear Lake near Houston, Texas. Until the new $60 million Manned Spacecraft Center is constructed, NASA puts temporary offices of key people in several buildings. In 1962, NASA is preparing for later flights to the Moon. The two-man Gemini spacecraft is being developed for Earth orbital flight tests, flown to learn more about spaceflight before the flight to the Moon. Project Gemini calls for buildup of mission length and complexity. By early January, a production mock-up of a two-man spacecraft to bridge the gap between the Mercury and Apollo programs is being built at McDonnell Aircraft Corporation. Gemini is an advanced version of the Mercury spacecraft. The shape, heat protection, and basic systems hardware are kept. In February 1962, wooden mock-ups of the Apollo lunar mission spacecraft are on hand and other tests are underway. Workers test sample materials for Apollo at high temperatures. Scientists try ablative heat shield materials of resin, microballoons, and nylon. Temperatures are from 2,600 degrees Fahrenheit on the side facing the quartz lamp heat source to 420 degrees on the other side. Construction of wooden command module mock-ups begins early in February. Scientists make electronic and computer studies. Mock-ups of cabin interior arrangements aid in the design of Apollo modules. Wind tunnel testing is a key factor in early development of the Apollo spacecraft. Workers test a command module and launch a escape tower test model in a 20-inch wind tunnel. Airflow goes to Mach 3.05. Meanwhile, astronauts train with the re-entry simulator trainer at Langley Station, Virginia. Returning from a moon mission, the guidance system can guide the spacecraft from re-entry into the Earth's atmosphere to either the prime or alternate landing point. 1962 is a good year for NASA. In addition to Glenn's orbital flight and progress on the Apollo program, 2 more Mercury orbital flights are good. Astronaut Carpenter flies 3 orbits, and Sherrod does 6.
I've liftoff, clock is started, and it feels real nice. Oh, you hear pins for this flight? Yeah, I got the pins on my office wall. I'll turn those off the tape. Stand by for 20 seconds. Okay. Stand by for Tico. Tico. I have Tico, cap set, and interlock stand, and it's very pleasant. Going to fly by wire low, going to fly by wire. That's fly by wire. Yours answering very nicely. Roll answers nicely. She's turning around very nicely.
The powerful Saturn rocket completes its first 2 test flights as the Apollo program rolls on, and NASA launches the first active communications satellite, Telstar 1. Workers put NASA's Relay Communications satellite in orbit. Another highlight of 1962 is the first launch of an international satellite. It's Britain's Ariel 1, which NASA places in orbit. That satellite takes measurements of the ionosphere. An exploration of the planets begins to produce results on December 14, 1962, when Mariner 2 becomes the first probe to fly by another planet. Mariner flies within 34,400 kilometers of Venus, scans its surface, and takes temperatures. NASA puts 2 more Tyros weather satellites in Earth orbit, and use of weather satellites is nearly routine, with the Weather Bureau using satellite data to help predict weather. NASA adds more astronauts to its NASA roster. On September 17, in Houston, officials present 9 new astronauts to the public. NASA selects them after more than 6 months of evaluation from 200 volunteers, both military and civilian. The new astronaut trainees are to start training with emphasis on space navigation, computer theory, and aerodynamic guidance and control. (1962) is the year the NASA Technology Utilization Program begins. The program is to transfer aerospace technology developments to the U.S. economy. Miniature components for the Mercury capsule are examples of some of the developments with potential for other uses in industry and at home. This is a Mercury capsule retrofire relay. It contains 50 components in a case about 3/4 of an inch by 1 inch by 1.5 inches. Preparations continue in the last half of 1962 for the first 2-man Gemini flight, which is to ultimately occur in March 1965. In preparation for Gemini, NASA develops more space technology. A Gemini spacesuit can be worn as long as 14 days. It is being tested for comfort and mobility. Boots, gloves, helmet. When attached to the suit, provide decompression protection during critical times of flight. The Apollo suit is so far the most difficult to develop. Scientists test freeze-dried dehydrated foods and concentrated bite-sized snacks packaged in edible coatings for space travel use. Water reconstitutes dehydrated food to its original texture. Freeze-dried foods include fruits, meats, and fish, which can be stored indefinitely without spoiling. Scientists study how well microorganisms live in a space environment. These studies of microorganisms are important before artificial environments for space crews on extended missions are created. After 1962 successes, even more NASA progress follows in 1963. To put 1963 in perspective, that is the year that the President's Science Advisory Committee cautions U.S. citizens on the use of pesticides. And on July 14, 1963, physicists say an elementary particle of matter is found. In 1963, NASA successfully launches 6 satellites and the last manned Mercury Earth orbital mission. NASA places 2 more weather satellites, Tyro 7 and 8, in orbit. They send almost 250,000 photos of weather information to Earth. And in 1963, NASA inserts the SYNCOM-2 communication satellite into an orbit 22,300 miles above the equator of the Earth. At that altitude, satellites orbit the world at a speed which synchronizes with the rotation of the planet's surface. So the satellite is stationary over one location on Earth. A communication satellite in a geosynchronous orbit is, in a sense, a broadcasting tower more than 22,000 miles high, which accounts for its great communications range. Scientists launched 3 scientific satellites, one of which is Explorer 18. Its long elliptical orbit allows radiation measurements in space almost to the moon in preparation for manned lunar flights. In May 1963, astronaut Gordon Cooper makes a 22-orbit flight around Earth. The spacecraft is Faith 7. The mission is normal until the second day. In the 19th orbit, the spacecraft 0.05 of a G light glows, erroneously signaling the start of re-entry. Later, scientists find the automatic stabilization and control system is not working. Cooper has to aim his spacecraft, fire retro-rockets, and control re-entry manually. He fires retro-rockets at the precise moment. Faith 7 splashes down within 4 4/10 miles of the carrier Kearsarge. NASA verifies man can operate efficiently during 1.5 days of weightlessness. With the flight of Faith 7, the Mercury program ends as a resounding success. In the meantime, work continues in preparation for 2-manned Gemini flights. Wind tunnel tests are done at the Langley Research Center with the Gemini shape. scientists evaluate a 1/52nd scale model in the hypersonic tunnel at Mach numbers 6.8 and 9.6. Objective? To see how stable Gemini will be during re-entry into Earth's atmosphere. Workers do stability tests in the 20-foot free-spinning tunnel with a small Gemini spacecraft model. Engineers study motions to see how well the drogue parachute will stabilize the falling capsule before the main chute opens. Work on Project Apollo continues as well. Scientists test drop a 1/4 scale model of the command module in calm water to get impact acceleration data. Workers make other drop tests of the model lunar lander on powdered pumice to simulate a lunar dust surface. Tests include various flight paths and contact velocity of 15 feet per second. While scientists and engineers develop Apollo spacecraft, astronauts prepare for lunar flights. At the Manned Spacecraft Center, scientists develop a computer program to simulate Apollo spacecraft control. The computer displays simulated spacecraft motions on the pilot's instruments panel. Using hand controls, the pilot responds to slow the module's approach to the lunar surface and to hover and pick the best spot for touchdown. Workers study spacecraft control problems of Apollo rendezvous and docking in space with computer simulation. From what the pilot sees on the instrument panel, there is little difference between simulated flight and real flight. Training continues as all 16 astronauts take part in a 4-day survival course at the U.S. Caribbean Air Command's Tropical Survival School in Panama. They spend 3 days and 2 nights in the jungle, learning what they might have to do to survive in case of an emergency tropical landing. We've reviewed some of the early progress of NASA. Join us next time for Episode 4 when we cover more of 1963 and 1964 when NASA receives the first close-up pictures of the Moon from a Ranger spacecraft. I'm Lynn Bondurant.
Roger, Columbia on a roll. Columbia, Houston, you're go at 40.
Roger, go at 40.